All right, welcome back, welcome back. Hey, isn't this a terrific venue? Aren't we so lucky to be here in this incredible venue? And it isn't just the venue that Seek have been like really accommodating with. They've just been so helpful this week with everything we've needed, with their time and their resources and people. It's just been great. And also having provided our next speaker. So Amy here is a senior iOS developer right here at Seek. She's passionate about solving problems with clean code and advocates for best practice and fostering a clean code culture. In the past few years, Amy's migrated a number of networking APIs to GraphQL in the Seek iOS codebase. And last year, she led a mobile app development team that migrated a 6-year-old legacy component over to GraphQL across iOS, Android, and on the web. So really well placed to talk to us about using GraphQL Schema across multiple front ends. So please join me in welcoming Amy today.
Thank you. Thank you. So, hi, I'm Amy. I'm very honored to be here with all of you, and I'm very excited to share my knowledge and expertise with all of you about building iOS app while designing a shared GraphQL schema across multiple front-end platforms. So I hope my insights and the learning would to help you to gain a better understanding. So this is our agenda for today. First, I will be introducing GraphQL, telling you the what and the why. And next, I will show you the app. Hopefully, you get an idea how the app experience is going to look like. And we will be using that app experience to review those learnings. And for all the learning, I will explain them with examples and a case study. And I hope that help you to gain a deeper understanding on this topic and to review those insights into the practice and the principles there. Towards the end of the session, there will be Q&A where you can ask me a question or share your thoughts, your experience. Okay, now let's get started. So first, what is GraphQL and why? On the official website, there is a definition there. It says GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives the clients the power to ask for exactly what they need and nothing more, makes it easier to evolve APIs over time, and enables powerful developer tools. That's a quite mouthful paragraph. And what are the takeaways out of it? To me, there are 4 things that are quite important. So first one, data in graphs. By defining a schema, all your data will be in graphs. And it's graphs all the way down, with top nodes composed of subnodes, and each subnode is going to have its own graphs. 2, GraphQL provides understandable description of your data, which means if you look at a schema and you find really hard to understand the data, and you couldn't tell where or how those data are going to be useful, that's probably a smell that the GraphQL schema needs to be changed. 3, only query what you need. If there are data or the fields as part of the schema that you're not going to use for your app experience, don't include them in your app. Otherwise, once you update your app and release your app to the App Store, those fields will be part of your older version of the app, and they're going to be much harder to deprecate them later on. And 4, easier to evolve. GraphQL is designed to make it easy to evolve over time, and you can add new types, new fields to your schema without breaking your existing code. You may wonder why GraphQL and what's the benefit of using it. Well, for a front-end engineer, a significant problem to solve is how you get all your data for your part of the app experience. With RESTful API, the response payload could be either too much data or sometimes not enough data, and you may end up calling a couple of network requests in order to get all the data you need. So when GraphQL came out, it was really hard to resist the promise that with only one single request, you're going to get all the data that you need for the part of the app experience. That also means less data transferred over the internet, which can be important for mobile devices with slow internet connections. Also, GraphQL uses a strong typed system. All the types that are exposed in the API are written down in the schema as a contract between the front end and the back end. The benefit of being a strong typed language is when that contract breaks, it's going to be easier to know that. Comparing to RESTful API, there's no versions in GraphQL, much easier to evolve the API as you go. And you can integrate multiple systems behind the GraphQL's API. It unifies them and hides the complexity. So for your legacy infrastructure or hybrid architecture, your existing RESTful API or even third-party APIs, GraphQL fetches the data from the existing system and packages it up in the response payload. Last but not least, the offline experience with caching is much easier to be achieved with the support that the Graph client and the tools that community provides. Offline support allows the app to operate with either no internet or very slow internet. So that includes reading data from your local cache, performing modification to your data optimistically, and synchronizing the local change with the server when the internet comes back, which is very cool. So before I start to show you the app experience, let's have a look at how the team was formed, and there's a tool called CodeGen. So in the team, we had product manager, designer, and the BA with us. For the developers, we had developers from iOS, Android, web, covering all the three front-end platforms. And we had a dedicated GraphQL team who are going to implement the GraphQL schema and resolve it for us. So there was a lot of discussion among those developers. So we know GraphQL uses a type system to clearly define the data for each type and the fields in the schema. And CodeGen is a tool that runs the code generation engine to generate Swift source code, in our case, based on the typed GraphQL queries. So let's have a look at the example. So in the picture on the left, so we have a GraphQL type named book, which has two fields, the title and author, both in string. So we need those data. So in the query, we pass in an ID to fetch the title and the author information. After we running the CodeGen tool, the Swift code is going to be look like on the right. So it's a struct of book with two properties, title and author. And we can use that struct as our data model. So please note that this is a very simplified example of the CodeGen result. The real CodeGen result is going to be a little bit more complex than this. But here it's just showing you the very essential stuff. So, and in the following example, I'll show you the app view with the GraphQL schema side by side. But I probably wouldn't show you the Swift code unless it's necessary. That's because the CodeGen tool is going to do the translation for us. Cool. Now let's have a look at the app experience. So this is a book review app. And on this view, it has two tabs. On top of the tab, this top section has some overview information of the book. And for those two tabs, for the About tab, there is a couple of sections like book overview and featured and the authors of the book. And in the Reviews tab, on the top, there's a summary section, and then followed by a list of each individual book review. OK, now let me start to share with you the 5 learnings that we had during that project. for all the landings, I'll share with you with examples where we went wrong, and then followed by the desired schema, and show you the best practices behind the idea. Okay, let's start. So the first question we had is, how should those up-level graph look like? And this is my first proposal. So there are 3 top-level fields: book, about, reviews. For the book fields and its subgraph, it's going to provide everything the top section needs on top of the tabs. The about field going to contain everything that needed for the about tab, and the reviews fields contain everything that the reviews tab needed. So the graph provides understandable description of the data, and I as a consumer feels really clear where and how I'm going to use those data. It seems to make perfect sense, but actually not. The reason is the data is coupled with the experience too tightly, and the GraphQL data was treated as a view model, which is going to cause trouble for us. So what if the UX design or the app experience changed in the future? What if we don't have tabs anymore? The GraphQL schema would not make any sense, and it would make people feel really hard to understand the data. Like the About field, for example. Today, it's really easy for us to tell, oh, this is for the About tab. But what if we don't have About tab anymore? Or what if we renamed that tab to be something else? Then when the consumer looks at this schema, they really scratch their head and have no idea what this About field is about. And we're not doing server-driven UI. The GraphQL schema is our contract and our common language, which provides the data for the front-end platforms. Meanwhile, give the freedom for the experience to evolve, and for each platform to choose how the experience would look like with flexibility. And based on that, this is what we agreed on the up-level fields. So the data and the experience are loosely coupled. The schema is having a good balance of keeping the cohesive data together on the one field, but also provide a structure to navigate consumers to discover the right information. So this is our first landing. The GraphQL schema is not our view model. The loosely coupled data with experience would give us the flexibility to change the experience in the future and make the schema itself sustainable and easier to evolve. Okay, now let's go down to some of the details. For this part of the UI, we need some data, like the average review score, the total number of the reviews. For those 2 progress bar, we need some average percentage number for the content rating and the reader recommendation rating. And for the carousel at the bottom, we need some average review score for each category, like the readability, recommendation, etc. Cool. You may notice that the schema going to cover 2 parts of different UI, and that's intentional. That's because those review score related data are cohesive data, and it makes sense to put them into one place in the graph, while the UI view has the flexibility to consume those data in 2 different UI places. Now let's have a look at the GraphQL schema proposal we got from the GraphQL team. And wow, this is a bit overwhelming. First, this is a super flat structure, and I can't really see the concept of graph. There are fields that providing data that actually not needed for this app experience at all. And when you look at the namings, there are a lot of common prefix there. It's probably a smell that those fields probably can be grouped together. So it turns out that this schema has been largely influenced by the Lexi system and the Lexi raw data there. So this is not a graph, and this is super hard for consumer to understand the data. When designing the GraphQL schema, it is preferred building the schema that describes how the client use the data, rather than mirroring your existing legacy database schema or your legacy raw data. After a few rounds of discussion and iterating on the graph side, this is what we settled with this new one. So more structure has been added, which helped understanding the data. And all those unused fields has been removed. Those common prefixes also been removed by grouping the fields with nested graphs. Now it's a lot more straightforward for the consumer to find and understand the right data for the specific experience. Let's take the content rating, for example. So that's for the first progress bar. So in the query, it has a value which provides the raw value of that review score so that it helps to animate the progress bar when it shows up. And it has a rating, which is a formatted number in percentage of that content rating, and followed by a description that's the label going to be need. So with graph, make sure you're thinking in graph. You model your business domain as a graph, and it's a graph all the way down. So with good naming for discovering the data and with shared understanding of your data. You may notice that in our example, some GraphQL fields return the raw data and others return formatted data. That's intentional as well. Here's another example. On the review list where we showed each individual book review, there's a requirement about the review posting date. So if the review posting date is less than a month, we say X days ago. But if not, we show the date by date, month, and followed by the year. Imagine if GraphQL just returns us the raw data, the date, then all the three front-end platforms, the iOS, Android, and the web, needs to have some local logic of implementing this formatting requirements. And this is where we see opportunity in GraphQL that it can consolidate that logic. By having the common logic in GraphQL, there is only one place to implement the details of that requirement instead of three. Besides, let's say if the requirement is going to be changed in the future with some other formatting requirements, then there would only be one place to make that change. And once that change has been made and deployed on the graph side, there's no need to update your app. There's no need to have an app release. And besides, all your older version of the app will be able to grab that latest formatted string from GraphQL. How cool is that? And now I want to talk a little bit more about sharing GraphQL schema across platforms. So based on my previous experience, there are several reasons why the GraphQL schema ends up fitting for one or two platforms, but not the other. It could be because of the experience discrepancy. As we're migrating the existing app experience, it's not unusual finding the experience surprisingly different on one platform from the other. Sometimes it's actually by design. Like a small edit view works really well by being a drop-down list on a big web page, while on the app, it makes sense to design a dedicated page for that editing in order to give you a focus on each screen. Regardless it's expected or not, when that happens, we need to consider all the platforms holistically. Having developers from all platforms working together and reviewing the schema draft is an effective way to eliminate the risk. But sometimes it's not possible to get the developers from all the front-end platforms working together at the same time. One or two platforms may start earlier than the other. When that happens, it's better to ask the one who not started yet to at least review the schema proposal or the PRs. It would be largely reduce the possibility of GraphQL rework or the need of introducing breaking change when they start to consume the schema later on. Another common scenario is GraphQL developer may not aware of the impact on the older version of the app, especially when there is a change to the GraphQL schema and it's gonna be a potential breaking change. For web, it's less an issue since the deploy of the fix would solve the issue fairly quickly and solve it everywhere. While for the apps, for those older versions of the app, it may cause crash and really impact your user from using your app until they can upgrade to the latest version. I'll talk about those potential breaking changes later. Now let's have a look at an example where the experience is different from web and app. So in our app, when we show the list of the book reviews, we show the 10 most recent reviews. And if the number of the review is less than 10, the label is gonna say showing all reviews. But that's actually an app-specific requirement. On the web, they show the full list of everything, all the reviews with pagination. And app decided this is our MVP and we're happy with the 10 most recent reviews. We're gonna do the pagination in the future. And the web decided they're gonna migrate to GraphQL later, not now. Knowing the differences exist, how do we handle that? The schema was designed in a way that is future-proof. So the schema includes the minimal fields that's required for the app to know whether there is more than one page of data, here like 10 reviews. Then we say showing 10 most recent review. Otherwise, less than 10, less than one page, we say showing all reviews. So by bringing the thinking up front for covering all the platform scenarios, it will enable the GraphQL schema to truly become a shared contract for all the front-end platforms. Now, let me share one of the most confusing bits in implementing the GraphQL types. I'm saying that because I saw many times that they went wrong in the PRs. The handling of the optional and non-optional data. So let's have a look at example in our book review app. So in the About tab, there is a section called Book Overview. For a book, it may have one or more information, including the website, the published date, the total page number, the binding type, and the description in text. They may or may not exist for a particular book, meaning they are optional data. Like the two screenshots shows here, the left one only has the website info and the description, while the right one has everything. We all know about how to handle the optional type in the Swift world. Imagine we need a data model for this. So we have a struct of overview where we have a struct called website with two properties, URL and the display name. Those two properties are non-optional because whenever we have the website information, we expect it always has a display name and with a link. But the website property itself is optional and the same to the others. And for the UI, if we see any of the properties new, we don't show the correspondence UI. If they has value, then we show those UI. How would that map to the GraphQL words? So GraphQL schema definition language use an exclamation mark to mark the non-optional data or what they call non-nullable fields. So inside the website type, the URL and the display name fields are non-nullable, while the website itself is actually nullable. And also the same to the other fields like published date, page count, bounding description. Which means in the payload of the data, those data may be absent. And for our UI, if we see any data comes in, we show the UI. If not, then we don't show them. That's how we achieved the data-driven UI. So now we covered the primitive type like a string, int, etc. And also the named type like the struct here. But there's also a very tricky one, array. While nullable array could indicate the data is optional, but the team agreed on using non-nullable empty array for the optional data. That's because it saves us from guarding the array to not to be new and also check the empty array everywhere. Well, the empty array itself is good enough for us to know that there's no data for the field. Yeah, finally, we tackled all the area and all the details, and we got our first version of the GraphQL, and the time to celebrate. After a while, you will face some sort of change to the GraphQL schema, and be aware of those potential breaking changes. Like if you want to change a field's type, or if you want to move the fields in or outside of nested fields, or if you want to add mandatory parameters or change your existing mandatory parameter to optional, then be aware of if any older version of the app is still consuming that schema, and making those changes gonna break the experience there. To eliminate the risk, it's important to future-proof when designing your GraphQL schema. And if you really need a breaking change, there are ways to introduce the new fields and deprecating the old one. For time limitation, I won't expand and explain here, but at least you as app developer needs to be aware of that and call out when it happens. And that's a unique risk only applied to app. Web would break, but usually less impact to them comparing to the app. Now let's recap. So GraphQL schema is not our view model. It's data in graphs. Loosely couple the experience and the data would help your GraphQL schema to be sustainable and give the freedom for the experience to evolve. Make sure your graph is understandable by grouping the cohesive data in graphs, providing good naming to the fields, removing any fields that you not needed, and consider if any common logic can be consolidated there. Make sure you and your team have upfront thinking for all the platforms, working together, reviewing the GraphQL schema to make it truly shareable across platforms. Make your non-optional data and optional data right by using the non-nullable fields and the nullable fields, and also be aware of any breaking changes. There are other cool things about the GraphQL, like by passing the locale parameter, the localization can be done at the GraphQL level. Again, one place for all the platforms. The GraphQL data payload can also support analytic tracking data. The offline experience and optimistic update on mutation with GraphQL tooling support is also very cool. If you're interested in any of those topics, find me, and I'm going to be very happy to have a chat about those great things. So here are some of the references that I use, and I recommend you to have a read if you're interested in. I hope you find this talk informative and useful. Thank you very much for being here.
Thank you, Amy. That was great. It's always great to hear from someone who's thought very deeply about a particular technology, not just how to do it, but how to do it well and cleanly. Tony, did you want to say something?
I just wanted to say, please ask lots and lots and lots of questions because lunch isn't here yet, so I'm panicking. So keep Amy very busy. Thank you.
Yes, ask your questions very slowly. Who has a question here? Great.
Hey, good morning. Thank you for the talk. Very informative. I wonder if you implemented a versioning strategy for your GraphQL API. There are multiple ways to bake version inside the data, inside the URL. Are you doing it? And if you do it, how?
So is your question about the versioning of the GraphQL schema itself, or is that manage the versioning of something else, like some...
The versioning of the GraphQL schema
itself, right?
Because over time, the schema will evolve, so how your front-end application are dealing with that? Okay,
that's a great question. So for the GraphQL, so probably coming from the RESTful API background, we know those RESTful API are going to have like V1, V2, V3, and they're going to keep remembering what's supported in this version, that version, and which one you test against in production. But with GraphQL, there is no such versioning. But there is a need to evolve the schema itself. So, so the way we do it at SIG is for example, there's a particular field that we really want to change the type of it. Maybe it was int, and now we decided it has to be string. The strategy we have is we introduce a new field according to that requirement, and then we mark the old one to be deprecated. But we can't delete it yet because the older version of the app is still consuming that. We don't want to introduce breaking change. And we just mark it as deprecate. And over time, we're monitoring how the older version of the app still consume those old fields. At Seek, it's actually, there is a very cool tooling developed by the GraphQL team. It's a dashboard based on the Datadog data, where it shows us how many requests are still like consuming particular fields. And that's going to give us a good insight of whether we can really delete it or not. Sometimes, if you really, really want to get rid of the old fields, you can force your user to upgrade your app to a particular version. But usually we don't do that because that's not a great experience. So the usual approach is, as I said, adding the new fields, mark the old one to be deprecate. Over time, we're monitoring it. And when the time comes that there is such a few number of requests, then we delete the old fields. Yeah. Thank you.
Any other questions? Yes.
That was a great talk, Amy. Thanks. Just had a quick question. You talked about moving the localization out of the front ends and up into GraphQL at a few different points in there. How does that cope and adapt to the user's on-device settings, things like time zones, 24-hour support? Does it adapt to those things, or is that something you need to roll in yourself?
That's a great question as well. So you're asking about how we manage like a time zone, like localization related settings, right? That's a very great question. So our journey was in our app, we actually have our own setting instead of using the phone's device setting. But then later on, we find out it's better to respect the device setting. So in the graph layer, we pass in the parameters like, so at the moment, we only passing like things like language, code, and country setting, so that at the GraphQL layer, like the backend, gonna know like which country or which language that they need to return us. Yeah. Is there any more information you want?
I guess it was just a bit in there. You could see on screen you were showing things like 26 days ago. And that number's obviously going to change slightly depending what time zone you're running the app in as well. So
yes, exactly. That's why we put those calculation at the back end, because by passing those parameters about the country and what the country and the time zone, then it could figure out like it's, because the logic is going to be all in the back end, and the front end wouldn't need to worry about that. It just shows whatever the back end give us, and it's across the platform. Yeah, thank you.
Sam.
Yeah, sorry, g'day. Yeah, really interesting talk. I love GraphQL, use it a lot. Been on the back end side many times now. Does your app do a single query for all the book details at once, or do you do sort of 3 queries for those 3 tabs that we see? And how do you decide how many queries you break up into?
Yes, cool. So that's also a good question. So the question is about how to break into separate queries for particular like app experience. So as the example I showed you, so this is a page with 2 tabs. So for that, we have 1 single query to fetch every data we need. That's because that's even it organized as 2 tabs, but the whole thing is the book review data, right? So it makes sense in the graph, it's just 1 graph containing all the book review stuff. But you may notice at the bottom of the tab there, bottom of the app, there are like other area like a recommendation or the profile And that's something that we split up, because in the graph, you're going to see the profile is like a one graph. The book review is another graph. So for my example, it's one single request. But if you want the data for the profile, for example, it's another GraphQL query. Yeah, no worries.
It's not a question. It's not a question because I work with Amy a lot, but it was more going on about the individual queries versus the one. And I think it depends on also like the experience, because with GraphQL, if you have those three sub-elements, if one fails and you do that query, then all fails. So you'd actually get null back. If you split it up into three, then you need to like at least accommodate your experience around that and go, okay, well, I've got the title, but then I've got nothing else. So I think it's experience driven also about like how you form your queries. But it's the one thing I actually hated about GraphQL was like if one bit fails or all of it fails, that used to kill me. Yeah.
Thanks, Jason.
I was just going to ask, do you ever get pushback from front-end people or even designers? Like, as a front-end guy, I guess I always feel like the data layer, I just want it to give me data. So I'm thinking about that example you gave where instead of giving you a date, it gave you a string of what to display in that field. And do you get pushback from your front-end people saying, is there ever that sort of tension between, just providing strings and saying, this is what you're going to display in your UI, and the front-end people saying, I'd like to have a little bit more data because I want the context of the information I'm showing in my app?
So I think what we love about the GraphQL is it can have multiple fields about particular information. In this example, if the front end really see the value of having the raw data, the date, it's also possible to have a field of the data type in the graph. And you can choose you want to consume it or not.
Right, so
Yeah.
that makes me feel better. All right, thank you, Amy. Please join me in thanking Amy for that great talk.
Thanks, everyone.